December 16, 1944, dawned cold and foggy across the Ardennes forest as Oberst Friedrich von der Heydte watched his elite paratroopers advance through the Belgian countryside, confident that Operation Watch on the Rhine would catch American forces completely unprepared for Germany's last great offensive. What he couldn't have anticipated was that American artillery shells would begin exploding above his formations with supernatural precision, detonating at exactly the right altitude to shower his men with deadly fragments without ever touching ground or trees. The first indication that something extraordinary was happening came at 08:15 hours when Hauptmann Klaus Müller's 3rd Company reported casualties from artillery fire that seemed to violate every principle of ballistics they understood. American shells were exploding 20 feet above German positions, with timing so perfect it appeared the enemy had developed some form of telepathic control over their munitions. Müller's radioed reports described explosions that occurred at optimal killing height, regardless of terrain variations or target movement. Artillery Oberst Heinrich Zimmermann, commanding the 5th Panzer Army's fire support, had spent 30 years mastering the mathematics of indirect fire, but the American shells falling on his advancing columns defied every calculation he had learned at German military academies. Contact fuses required physical impact to detonate, while time fuses demanded precise calculation of flight duration to achieve airburst effects. These American rounds were exploding at perfect altitude without either requirement being met. The technology that was devastating German formations represented one of the war's most closely guarded secrets. The proximity fuse, developed jointly by American and British scientists as part of a classified program that had consumed millions of dollars and thousands of research hours. These electronic marvels contained miniature radar systems that could detect approaching targets and detonate artillery shells at optimal distance for maximum fragmentation effect against personnel and light vehicles. General Gerd von Rundstedt, commanding Army Group West, received increasingly frantic reports from unit commanders who described American artillery achieving unprecedented accuracy against moving formations. German soldiers were dying from shell fragments that seemed to rain from empty sky, with no visible explosion points or impact craters to explain the carnage that was decimating attack formations before they could reach their objectives. According to classified technical reports preserved in the National Archives, proximity fuse development represented collaboration between Johns Hopkins Applied Physics Laboratory and British radar specialists, producing weapons that increased artillery effectiveness by factor of 5 against personnel targets. The psychological impact on German troops was as devastating as the physical casualties. Veterans who had survived years of conventional artillery fire found themselves facing weapons that seemed to possess supernatural intelligence, exploding at precisely the right moment to maximize killing potential. The technology appeared so advanced that some soldiers began reporting that American forces had developed death rays or other science fiction weapons. Lieutenant Colonel Rudolf Christoph, leading an armored reconnaissance battalion toward Malmedy, watched his vehicles come under artillery fire that achieved direct hits on moving targets with consistency that exceeded human capability. His after-action reports described shell bursts that occurred directly above tank formations, suggesting American observers possessed impossible accuracy in range calculation and timing coordination. The proximity fuse represented American technological superiority applied to solving fundamental artillery problems that had plagued military forces throughout history. Traditional contact fuses required direct impact for detonation, while time fuses needed precise calculation of flight duration that often resulted in shells exploding too high or too low for maximum effectiveness. The new electronic fuses eliminated guesswork by measuring actual distance to targets and detonating at optimal range automatically. German intelligence officers interrogating captured American artillery personnel initially dismissed descriptions of electronic fuse technology as deliberate disinformation designed to conceal superior observation techniques or fire control methods. The concept of miniaturized radar systems installed in individual artillery shells seemed beyond current technological capability, even for American industrial capacity that had already produced innovations German scientists considered impossible. As December 16th progressed and German casualties mounted from artillery fire that achieved unprecedented effectiveness, field commanders began reporting to higher headquarters that American forces had deployed revolutionary weapons systems that rendered conventional tactical approaches obsolete. The surprise that was supposed to characterize Operation Watch on the Rhine was being turned against German forces through technology they had never encountered and couldn't comprehend. Dr. Merle Tuve hunched over electronic oscilloscopes in his Johns Hopkins Applied Physics Laboratory throughout the winter of 1943, debugging miniature radar circuits that would soon revolutionize artillery warfare in ways that German scientists had never imagined possible. His team was solving fundamental problems of electronics miniaturization while developing proximity fuses that could survive artillery acceleration forces exceeding 20,000 gravities during shell firing. The technical challenges seemed insurmountable to conventional engineering approaches. Radio tubes small enough to fit inside artillery shells had to withstand acceleration forces that would destroy normal electronic equipment, while maintaining sensitivity sufficient to detect reflected radar signals from targets dozens of feet away. The circuitry required power supplies, antennas, and detection systems that could operate reliably after experiencing launch stresses equivalent to automobile crashes. British radar specialist Dr. William Penny contributed crucial developments in microwave technology that enabled proximity fuses to distinguish between legitimate targets and environmental interference that might cause premature detonation. His algorithms prevented shells from exploding when detecting birds, rain, or other non-threatening objects while maintaining sensitivity to human targets and military equipment that represented valid engagement criteria. The manufacturing process developed by Western Electric Corporation represented precision production techniques that German industry couldn't replicate under wartime conditions. Each proximity fuse contained over 100 individual components, assembled with tolerances measured in thousandths of inches, requiring quality control procedures that exceeded German capacity for mass production of complex electronic systems during resource-constrained total war. Colonel Leslie Skinner, coordinating proximity fuse testing at Aberdeen Proving Ground, conducted live fire evaluations that demonstrated effectiveness improvements exceeding 500% compared to conventional time fuses against personnel targets. His statistical analysis proved that electronic fuses achieved optimal burst altitude 95% of the time, while traditional fuses required guesswork that produced appropriate air bursts less than 20% of successful firings. Technical development records from Johns Hopkins Applied Physics Laboratory archives document the systematic solution of miniaturization problems that enabled proximity fuse deployment as decisive battlefield advantage during crucial European theater operations. The security surrounding proximity fuse technology rivaled Manhattan Project classification levels, with researchers working under compartmentalized conditions that prevented any individual from understanding complete system design. Scientists developing radar components were isolated from colleagues working on power supplies or detonation mechanisms, ensuring that captured personnel couldn't reveal comprehensive technical details even under intensive interrogation. American artillery officers received extensive training on proximity fuse employment, while remaining ignorant of underlying technical principles that enabled their revolutionary capabilities. Battery commanders learned optimal tactical applications without understanding electronics theory, maintaining operational security while maximizing battlefield effectiveness through specialized training programs conducted at classified facilities away from potential enemy observation. The production statistics revealed American industrial advantages that German intelligence had systematically underestimated throughout the conflict. Western electric factories were manufacturing proximity fuses at rates exceeding 50,000 units monthly by late 1944, representing precision electronic production that exceeded German capacity for all military electronics combined, including radar systems and communications equipment. German scientists captured during earlier campaigns had been interrogated about proximity fuse possibilities, with most dismissing the concept as technically impossible given miniaturization requirements and power supply limitations. Their assessments contributed to German unpreparedness for encountering weapons that seemed to violate physical principles they understood about electronics reliability under extreme mechanical stress. The radar principles employed in proximity, fuses utilized frequencies and power levels that German electronic warfare specialists had never encountered, making detection and countermeasure development extremely difficult even after captured examples became available for technical analysis. The sophistication exceeded German radar technology by generations, representing research and development investments that Axis powers couldn't afford during resource-constrained warfare. Testing protocols developed at Aberdeen Proving Ground had revealed optimal employment techniques that maximized proximity fuse effectiveness against various target types while minimizing ammunition consumption and logistical requirements. American artillery units learned to coordinate fire missions that created overlapping burst patterns capable of neutralizing entire enemy formations with precision that conventional fuses could never achieve. Oberst Reinhard Gehlen stared at captured American artillery shells in his Army Group Center intelligence facility, unable to comprehend the electronic components visible through damaged fuse assemblies that bore no resemblance to German ordnance technology. His technical specialists had been analyzing these mysterious devices since November 1944, when German forces first encountered ammunition that seemed to detonate through supernatural timing rather than conventional mechanical or chemical mechanisms. The interrogation reports from captured American artillery personnel contained descriptions of VT fuses and radio-controlled shells that German translators initially dismissed as propaganda designed to conceal advanced optical sighting techniques or superior meteorological prediction methods. The concept that individual artillery rounds could contain functional radar systems seemed beyond technological possibility, even for American industrial capacity that had already produced innovations German scientists considered impossible. Major Wolfgang Martini, directing Luftwaffe signals intelligence operations, had intercepted radio communications that referenced proximity fuse deployment without providing technical details that would enable German countermeasure development. His analysis suggested American forces possessed electronic warfare capabilities that exceeded German understanding of miniaturization limits and power supply efficiency in battlefield environments. German research establishments had investigated proximity fuse concepts during peacetime development programs, but abandoned the projects due to insurmountable technical challenges related to component miniaturization and survivability under artillery acceleration forces. Dr. Hans Kammler's Weapons Research Division concluded that electronic fuses represented theoretical possibility, but practical impossibility given manufacturing constraints and reliability requirements. The captured proximity fuse components were distributed among German technical institutions for analysis, with each facility focusing on specific subsystems while remaining ignorant of overall design philosophy that enabled American success in solving problems German scientists had considered unsolvable. The compartmentalized approach that protected American security also limited German understanding of systematic solutions that made proximity fuses operationally viable. German intelligence assessments preserved in captured Wehrmacht archives reveal systematic underestimation of American technical capabilities and industrial capacity for precision electronics production throughout the war. Field commanders reporting proximity fuse encounters described artillery effects that exceeded conventional weapons by margins that suggested completely different physical principles governing shell detonation and fragmentation patterns. German soldiers were experiencing casualties from airbursts that occurred at optimal killing height, regardless of terrain variations or target movement patterns that should have affected traditional time fuse accuracy. The psychological warfare implications were as significant as tactical advantages, with German troops developing superstitious explanations for artillery that seemed to possess supernatural timing and targeting capabilities. Reports from frontline units described American shells that knew when to explode for maximum effectiveness, creating fear and uncertainty that undermined military discipline and tactical coordination. German electronic warfare specialists attempted to develop jamming techniques that might interfere with proximity fuse operation, but their efforts were hampered by incomplete understanding of radar frequencies and power levels employed in American systems. The countermeasures research proceeded without access to captured examples that could reveal technical specifications necessary for effective interference development. The industrial intelligence that German economic warfare analysts had compiled about American manufacturing capacity had failed to account for precision electronics production that enabled proximity fuse mass production at scales sufficient for widespread battlefield deployment. German estimates of American technical capabilities had been based on peacetime commercial production that bore little resemblance to wartime precision manufacturing capacity. Propaganda. Minister Joseph Goebbels received briefings about American proximity fuse technology, but decided against publicizing the weapons for fear of undermining German morale through acknowledgement of enemy technical superiority that German research couldn't match or counter effectively. The decision to maintain silence contributed to continued German unpreparedness for encountering revolutionary artillery systems. The technical analysis conducted by German scientists revealed individual proximity fuse components that represented manufacturing precision and miniaturization techniques that exceeded German capability for mass production under wartime conditions. The vacuum tubes alone required production tolerances that German electronics industry couldn't maintain while meeting other military electronics requirements, including radar systems and communications equipment. As German forces advanced into the Ardennes during Operation Watch on the Rhine, their intelligence preparation had failed to account for proximity fuse deployment that would transform American artillery effectiveness from conventional support weapon to precision instrument capable of neutralizing entire formations through coordinated electronic timing that eliminated guesswork from indirect fire operations. Hauptmann Ernst Barkmann crouched behind his disabled Panther tank near Bastogne on December 20, 1944, watching American artillery shells explode in perfect airbursts above his scattered company, while fragments rained down on German soldiers who had nowhere to hide from weapons that seemed to detonate at precisely calculated altitude for maximum casualties. His radio operator's final transmission had described American fire control that achieved supernatural accuracy against moving armored formations. The mathematics of destruction were becoming apparent to German officers who had survived initial proximity fuse encounters. American artillery was achieving kill ratios that exceeded conventional munitions by factors that transformed tactical calculations about acceptable casualty rates during offensive operations. Formations that should have sustained manageable losses during river crossings or urban assaults were being decimated by air bursts that eliminated entire platoons within minutes. General Heinrich von Luttwitz, commanding the 47th Panzer Corps, received casualty reports that described American artillery achieving effectiveness levels that made continued offensive operations impossible without massive reinforcement that German reserves couldn't provide. His headquarters estimated that proximity fuse employment was reducing German combat strength at rates 3 times higher than conventional artillery could achieve under similar circumstances. The fragmentation patterns created by proximity fuses were optimized for anti-personnel effect through scientific calculation of burst height and shrapnel dispersion that German ordnance specialists had never achieved with traditional time fuses. American shells were detonating at altitudes that created cone-shaped killing zones, perfectly suited to neutralizing infantry formations and crews of open vehicles who couldn't find adequate cover. Colonel James Polk, commanding American artillery supporting the 101st Airborne Division, coordinated fire missions that utilized proximity fuse technology to break up German armored attacks with precision that exceeded his most optimistic expectations. His battery commanders reported ammunition effectiveness that reduced required firing time and shell consumption while achieving target neutralization that conventional fuses could never accomplish. After-action reports from European Theater of Operations archives document proximity fuse employment that increased American artillery effectiveness by margins that fundamentally altered tactical balance during Battle of the Bulge operations. German medical personnel treating proximity fuse casualties observed wound patterns that differed significantly from conventional artillery injuries, with multiple small puncture wounds from optimally fragmented shrapnel rather than large lacerations from shell fragments that typically resulted from ground bursts or poorly timed air bursts. The medical evidence confirmed that American munitions were designed specifically for anti-personnel effectiveness. The tactical adaptation required by proximity fuse employment challenged German defensive techniques that had been developed during years of conventional artillery combat. Traditional methods of seeking cover in buildings, trenches, or behind natural obstacles provided little protection against air bursts that showered fragments downward from optimal altitude calculated to defeat standard protective measures. Lieutenant Otto Schmidt, surviving commander of a reconnaissance company that had been virtually eliminated by American proximity fuse fire, reported that German soldiers were psychologically unprepared for artillery that seemed to possess artificial intelligence capable of timing detonations for maximum killing effect. His men had begun refusing to advance across open terrain where American observation could direct electronic munitions against them. The logistical implications were becoming apparent to German supply officers who observed that American artillery was achieving unprecedented target destruction ratios with reduced ammunition expenditure compared to conventional fire missions. Proximity fuses were enabling American forces to neutralize German formations while conserving shells that traditional tactics would have required in much larger quantities to achieve equivalent results. German tank crews reported that proximity fuses were particularly effective against armored vehicles by targeting commanders and external equipment while avoiding direct engagement with main armor that might deflect conventional shells. American artillery could disable German tanks by eliminating crews and damaging sighting equipment without requiring direct hits that conventional anti-tank munitions demanded for successful engagement. The coordination between American observation posts and artillery batteries had been enhanced by proximity fuse technology that eliminated timing calculations traditionally required for effective airburst employment. Fire direction centers could focus on target location, rather than complex mathematical computations needed to achieve proper burst height with conventional time fuses that required precise flight duration estimation. As German forces bogged down throughout the Ardennes salient, proximity fuse casualties were accumulating at rates that exceeded German replacement capacity and medical treatment capability, with American artillery achieving strategic effects through tactical innovation that was transforming the fundamental nature of indirect fire support in modern warfare. General Maxwell Taylor established his 101st Airborne Division command post in Bastogne's basement on December 19, 1944, knowing that proximity fuse technology would enable his artillery to break German siege attempts with effectiveness that exceeded conventional defensive capabilities by margins that could determine whether the surrounded garrison could maintain resistance until relief forces arrived. The Fire Direction Center, operating beneath Bastogne's main square, coordinated proximity fuse employment with mathematical precision that transformed American artillery from area weapon into point target system capable of neutralizing specific German formations with minimal ammunition expenditure. Battery commanders reported achieving kill ratios that exceeded peacetime training projections by factors that seemed impossible under actual combat conditions. Lieutenant Colonel Paul Danahy, directing artillery support for besieged American forces, discovered that proximity fuses enabled his limited ammunition supplies to achieve maximum effectiveness against German attackers who had no defense against airbursts that detonated at optimal altitude regardless of terrain features or weather conditions. His guns were achieving tactical effects that would have required 10 times more conventional ammunition to accomplish. The technical training that American artillery officers had received in proximity fuse employment was proving decisive in combat situations where conventional tactics would have failed against superior German numbers and armor. Battery commanders could coordinate fire missions that created overlapping killing zones above German approach routes while conserving shells through electronic timing that eliminated guesswork from indirect fire operations. Master Sergeant William Henderson, operating the fire direction computer for the 463rd Parachute Field Artillery Battalion, calculated proximity fuse settings that enabled his 12-pack howitzers to break up German armored attacks with precision that larger artillery formations couldn't achieve using conventional time fuses, requiring complex mathematical calculations for effective airburst employment. Artillery effectiveness studies conducted by the Army Field Artillery School document proximity fuse performance improvements that revolutionized American indirect fire doctrine and tactical employment throughout European theater operations. The psychological impact on American troops was as significant as tactical advantages, with infantry soldiers reporting increased confidence in artillery support that could neutralize German attacks before enemy forces reached assault positions. The reliability of proximity fuse detonation eliminated uncertainty about whether fire missions would achieve intended effects against advancing German formations. American observation posts coordinated with artillery batteries to maximize proximity fuse effectiveness through target designation that enabled guns to achieve optimal burst patterns above German concentrations. Forward observers learned to identify terrain features and enemy formations that presented ideal targets for electronic fuse employment that conventional munitions couldn't engage as effectively. The logistics revolution enabled by proximity fuse technology allowed American artillery units to achieve sustained fire support with reduced ammunition consumption compared to conventional operations, requiring massive shell expenditures to achieve equivalent target neutralization. Supply officers reported that electronic fuses were enabling artillery missions to achieve strategic effects through tactical efficiency. Radio communications between American artillery units revealed coordination techniques that maximized proximity fuse employment against German counterattacks while minimizing friendly fire risks through electronic timing that ensured detonation occurred at safe distances from American positions. The technology eliminated many safety concerns that had limited conventional artillery support in close combat situations. American tank commanders reported that proximity fuse artillery provided unprecedented protection against German infantry anti-tank teams by creating defensive zones that infantry couldn't penetrate without taking casualties that exceeded their ability to sustain effective operations. The electronic timing enabled artillery to engage targets that conventional fuses couldn't neutralize reliably. The tactical doctrine developed for proximity fuse employment emphasized mass effects through coordinated battery fire that created overlapping burst patterns capable of neutralizing entire German formations simultaneously. American artillery was learning to coordinate electronic timing across multiple guns to achieve synergistic effects that exceeded simple addition of individual shell effectiveness. Training modifications implemented during combat operations taught American artillery crews to exploit proximity fuse capabilities that conventional munitions couldn't provide, including engagement of targets in defilade positions and neutralization of moving formations without requiring precise range calculation that time fuses demanded for effective employment against dynamic battlefield situations. The revolution in American artillery effectiveness was transforming tactical balance throughout the European theater, with proximity fuses enabling inferior American formations to achieve defensive success against superior German forces through technological advantages that compensated for numerical and positional disadvantages. General Oberst Alfred Jodl convened emergency meetings at Oberkommando der Wehrmacht headquarters on December 22, 1944, demanding explanations for casualty reports that described American artillery achieving effectiveness levels that exceeded German intelligence estimates by margins that suggested revolutionary weapons deployment. His staff officers struggled to comprehend tactical situations where American forces were neutralizing entire German formations with artillery fire that seemed to violate fundamental principles of ballistics and target engagement. German field commanders were developing desperate tactical modifications to counter proximity fuse employment, including movement techniques that emphasized dispersed formations and rapid displacement to minimize exposure to American artillery that could achieve lethal airbursts regardless of cover or concealment that had previously provided protection against conventional indirect fire. The adaptations reduced tactical effectiveness while increasing coordination complexity. Oberst Rudolf Christoph attempted to train his armored reconnaissance battalion in evasive maneuvers designed to defeat American proximity fuse fire, but discovered that electronic timing eliminated most advantages of speed and unpredictable movement patterns that had been effective against conventional artillery employment. His vehicles were being engaged with accuracy that suggested American observers possessed supernatural target tracking capabilities. The medical evidence accumulating in German field hospitals revealed wound patterns consistent with optimized fragmentation from airbursts that occurred at calculated altitude for maximum anti-personnel effect. German doctors were treating injuries that demonstrated scientific precision in shell timing and fragment dispersion that exceeded conventional munitions by significant margins, measurable through statistical analysis of casualty types. German artillery officers attempted to develop countermeasures against proximity fuse technology through electronic jamming techniques, but their efforts were hampered by incomplete understanding of radar frequencies and power levels employed in American systems. The jamming equipment available to German forces had been designed for different applications and proved ineffective against proximity fuse operation. German tactical modifications documented in captured Wehrmacht field manuals reveal systematic attempts to adapt conventional tactics to counter American proximity fuse employment with limited success due to technological disadvantages. The propaganda implications of proximity fuse casualties were carefully managed by German military censors who suppressed frontline reports describing American artillery that seemed to possess artificial intelligence capable of timing detonations for optimal killing effect. The censorship contributed to continued German unpreparedness for encountering revolutionary weapons systems throughout remaining operations. German engineers captured American proximity fuse components and attempted reverse engineering efforts that revealed manufacturing precision and miniaturization techniques beyond German industrial capacity under wartime resource constraints. The technical analysis demonstrated American capabilities that German scientists had considered theoretically possible, but practically impossible given known limitations of electronic component production. Field Marshal Gerd von Rundstedt modified German offensive tactics to account for American proximity fuse deployment by emphasizing night operations and weather conditions that might limit American observation and fire control effectiveness. The tactical changes reduced German operational flexibility while failing to eliminate proximity fuse advantages that functioned regardless of visibility conditions. German intelligence services attempted to recruit agents within American artillery units to obtain technical specifications for proximity fuse technology, but security surrounding the weapons exceeded penetration capabilities of German espionage networks operating under increasingly constrained conditions as Allied counterintelligence efforts eliminated German information sources throughout occupied territories. The psychological impact on German soldiers was documented through intercepted letters and diary entries that described American artillery possessing supernatural timing and targeting capabilities that created fear and uncertainty among troops who had previously adapted to conventional indirect fire through experience and tactical training. The psychological warfare effects undermined German military discipline and unit cohesion. Training modifications attempted by German military schools emphasized dispersal techniques and rapid movement procedures designed to minimize casualties from American proximity fuse employment. But the instruction came too late to affect units already engaged in Ardennes operations, where proximity fuse technology was achieving decisive tactical effects against German formations. German quartermaster services began developing protective equipment designed to reduce proximity fuse casualties, including improved helmets and body armor optimized for overhead fragment protection. But the manufacturing requirements exceeded German industrial capacity, already strained by competing military equipment priorities that included conventional weapons and ammunition production for ongoing operations. The tactical balance throughout the European theater was shifting in favor of American forces whose proximity fuse technology was enabling inferior formations to achieve defensive and offensive success against superior German numbers through technological advantages that German adaptation efforts couldn't effectively counter within time constraints imposed by accelerating Allied operations. Colonel Charles Gow observed American artillery operations from his 1st Army headquarters on December 25, 1944, calculating that proximity fuse employment was achieving German casualty rates that exceeded conventional munitions effectiveness by 400%, while reducing American ammunition consumption through electronic timing that eliminated the guesswork traditionally required for successful airburst employment against personnel targets in varied terrain conditions. The statistical analysis conducted by American operations research teams revealed proximity fuse performance data that confirmed laboratory predictions about increased artillery effectiveness translated into battlefield results. German formations were being neutralized with shell expenditures that represented 60% reduction compared to conventional time fuse requirements for achieving equivalent target destruction against similar tactical situations. General Omar Bradley's 12th Army Group intelligence summaries documented German tactical modifications that attempted to counter proximity fuse advantages through dispersal techniques and rapid movement procedures, but noted that German adaptations reduced their operational effectiveness while failing to eliminate American artillery advantages that functioned regardless of enemy countermeasures or environmental conditions. The technological superiority demonstrated by proximity fuse deployment was influencing strategic planning for remaining European operations, with American commanders developing offensive concepts that relied heavily on artillery support that could neutralize German defensive positions with precision that conventional munitions couldn't achieve. The weapons were enabling tactical innovations that reduced American casualty rates while accelerating operational tempo. German prisoner interrogations revealed widespread confusion and fear regarding American artillery that seemed to possess artificial intelligence capable of timing detonations for optimal effect against personnel and light vehicles. German soldiers consistently reported psychological stress from facing weapons that appeared to violate physical principles they understood about conventional indirect fire employment and defensive techniques. Strategic assessment reports from European Theater of Operations headquarters document proximity fuse impact on tactical balance that enabled American forces to achieve operational objectives with reduced casualties and ammunition consumption throughout remaining European campaigns. American artillery doctrine was evolving rapidly to exploit proximity fuse capabilities that conventional training hadn't anticipated, with battery commanders learning to coordinate electronic timing across multiple guns to create overlapping burst patterns that could neutralize entire German formations simultaneously through synchronized detonation at optimal altitude above target areas. The industrial implications were becoming apparent to military planners who recognized that proximity fuse production represented American technological and manufacturing advantages that German industry couldn't replicate under wartime conditions. The weapons demonstrated capabilities that reflected research and development investments that Axis powers hadn't made during peacetime preparation for modern warfare. German defensive tactics were adapting to proximity fuse threat through emphasis on underground positions and armored protection that could deflect overhead fragments. But the modifications required resources and construction time that German forces couldn't afford while conducting mobile operations under constant pressure from advancing Allied formations equipped with revolutionary artillery systems. The coordination between American infantry and artillery was enhanced by proximity fuse technology that enabled close support missions without complex safety calculations traditionally required to prevent friendly casualties from poorly timed airbursts. Infantry commanders could request artillery support with confidence that electronic timing would ensure safe detonation distances from American positions. German medical services were overwhelmed by proximity fuse casualties that required treatment techniques different from conventional artillery wounds, with multiple small fragment injuries that demanded specialized surgical procedures that German field hospitals couldn't provide under combat conditions. The medical burden contributed to German logistical strain throughout remaining operations. The tactical lessons learned from proximity fuse employment were being incorporated into American military doctrine that would influence post-war artillery development and training programs. The weapons had demonstrated that electronic technology could revolutionize conventional military capabilities through scientific solutions to traditional problems that had limited artillery effectiveness throughout military history. American ammunition manufacturers were increasing proximity fuse production to meet demand from field commanders who reported unprecedented tactical advantages from electronic timing technology. The weapons were proving so effective that conventional time fuses were being relegated to secondary applications where electronic alternatives weren't available or appropriate for specific tactical situations. The strategic impact of proximity fuse technology extended beyond immediate Battle of the Bulge operations to fundamental questions about future warfare, where electronic systems would increasingly determine tactical advantages through technological superiority rather than traditional factors of numbers, training, or tactical innovation that had previously governed military effectiveness. Lieutenant General Courtney Hodges submitted his First Army After-Action Report on February 15, 1945, documenting proximity fuse performance that had achieved German casualty rates exceeding conventional artillery effectiveness by margins that fundamentally altered tactical calculations about required ammunition expenditures and expected operational timelines. His analysis confirmed that electronic timing technology had revolutionized American artillery from area weapon into precision instrument, capable of neutralizing specific targets with scientific accuracy. The German surrender documents captured at war's end contained technical intelligence assessments that revealed Wehrmacht recognition of American proximity, fuse superiority, and acknowledgement that German forces had no effective countermeasures against electronic timing technology that eliminated traditional defensive techniques. German military leaders admitted that proximity fuses had contributed significantly to tactical defeats throughout final European operations. Post-war interrogation of German artillery specialists confirmed that Wehrmacht forces had never developed comparable electronic fuse technology due to resource limitations and technical challenges that German scientists had considered insurmountable given miniaturization requirements and reliability standards necessary for battlefield employment under extreme mechanical stress conditions during artillery firing and flight operations. Dr. Merle Tuvey's research team at Johns Hopkins Applied Physics Laboratory received presidential recognition for developing weapons that had saved thousands of American lives while accelerating Allied victory through technological innovation that demonstrated American scientific and industrial superiority over Axis research efforts. The Proximity Fuse program represented successful collaboration between academic research and military requirements that produced decisive battlefield advantages. The statistical analysis of Battle of the Bulge casualties revealed that American forces equipped with proximity fuses had achieved defensive success against superior German numbers through artillery effectiveness that exceeded traditional capabilities by factors that compensated for numerical disadvantages. German formations had sustained casualties that made continued offensive operations impossible despite initial tactical advantages. Comprehensive post-war analysis published in The Army Air Forces in World War II documents proximity fuse development as decisive technological advantage that influenced tactical balance throughout European theater operations and established precedents for electronic warfare systems development. American military doctrine incorporated proximity fuse lessons into artillery training programs that emphasized electronic timing advantages while developing tactical procedures that maximized coordination between observation posts and battery positions to exploit technological capabilities that conventional munitions couldn't provide. The weapons had established new standards for indirect fire effectiveness and precision. German military historians acknowledge that proximity fuse technology represented American technological achievement that German research couldn't match, despite having recognized the theoretical possibilities during peacetime development efforts. The weapons demonstrated industrial capacity for precision electronics manufacturing that exceeded German understanding of mass production techniques for complex electronic systems. The security classification surrounding proximity fuse development was maintained throughout the war and extended into post-war periods to prevent Soviet acquisition of American electronic warfare technology. The compartmentalized research approach had successfully protected revolutionary weapons from enemy intelligence while enabling rapid development and deployment under combat conditions. Veterans Administration medical records documented reduced American casualty rates in units supported by proximity fuse artillery compared to formations relying on conventional munitions, confirming battlefield reports about increased artillery effectiveness that had enabled American forces to achieve tactical objectives with lower personnel losses than traditional operations required for equivalent results. The industrial production statistics revealed that American factories had manufactured over 20 million proximity fuses during the war, representing precision electronics manufacturing that exceeded global production of similar devices while maintaining quality standards that ensured reliable battlefield performance under extreme conditions that conventional electronic equipment couldn't survive. International military observers studying Battle of the Bulge operations identified proximity fuse employment as revolutionary development in artillery technology that established precedents for electronic warfare systems that would dominate future military conflicts. The weapons had demonstrated that scientific research could produce decisive battlefield advantages through technological innovation rather than traditional military approaches. The legacy of proximity fuse technology extended beyond immediate military applications to civilian electronics development that utilized miniaturization techniques and reliability standards developed during wartime research programs. The scientific knowledge gained during fuse development contributed to post-war advances in radar systems, communications equipment, and eventually civilian electronics that transformed modern society. American military supremacy established during World War II had been built partly on technological advantages like proximity fuses that demonstrated superior research capabilities and industrial capacity compared to Axis powers. The electronic warfare revolution that began with artillery timing devices would eventually encompass all aspects of modern military operations through continuing development of scientific solutions to traditional battlefield challenges.